Good afternoon friends, I welcome you all in this session. In this session we are going to see probability models in networks. Though we have seen a couple of issues related to probability when we were discussing about Hillier models. In fact, when we were looking at risk analysis in standalone projects, so there we have seen Hillier model, right? So some of the things related to probability has already been covered, but let me tell you how probability helps you in knowing whether the duration of the project would be achieved in a particular period of time or not, right? So let's get started. All of you would have seen this curve. This is a normal curve, a bell shaped curve. The area under curve is unity, right? It's always 1, right? And this is quite a symmetric curve, and this is the central tendency of this particular curve, right? Central tendency is something where the whole distribution rests, right? So this is mean of this curve, right? Since this is a symmetric one, so this is this point is actually mean, mode and median, right? This point is mean, mode and median, right? So this is a curve which we would be using in our calculation of duration of various projects, right? So if you look at this curve, it has got two sides. You have got 1 sigma, 2 sigma plus 3 sigma, right? So mean plus minus 1 sigma, mean plus 2 sigma and mean plus 3 sigma, right? This side mean minus 1 sigma, mean minus 2 sigma and mean minus 3 sigma. So in this curve, the characteristics of this curve is that within plus minus 3 sigma limits, you will have 99.7% of the area. Within 2 sigma limits, the area under curve is 95.4%, and within 1 sigma limit you have got 68.2% area. So we will use this this information in solving couple of questions. So far we have calculated T and TLs for the networks, and let us look at, and I have also said that T at the last node is nothing but the duration which a project will take for its completion, right? And TS is nothing but scheduled completion time, which would be given by your client. If scheduled completion time TS is not given, then T is equal to TL, right? Let us look at this example wherein this is TE, right, which is also equal to TS, right? Since there is no difference, so we will say the probability of completion of this project is, let us say, 50%, right? So this area is 50%, right, this area, and remaining this area is also 50%. So this total area is 100%. Now you should ask, you should answer my question, and the question is, if TS, if this value is towards left of TE, let us say if it is here, is left of T, then the area under curve would be what? If this TS value is 1 standard deviation, let us say somewhere here, let me draw this curve. So this is your normal distribution curve, right? This is your TE, and at this point TS is also this, right? Now if TS is this, let us say this is TS, and this is 1 standard deviation away from here, 1 sigma and this is your mu. So what would be the area? What would be the area? What would be this area? Can anybody tell me, or can you tell me? I know that this total area is 50%, right? And one standard deviation towards left and towards right is at 68.2. So this is mu minus 1 sigma, this is mu plus 1 sigma, right? So this area is 68.2. What would be this area? This area would be 50% minus 34 point. This area is 34.1, this area is 34.1, right? So 50 minus 34.1, isn't it? So we'll say that this area is 15.9, this area is 34.1, right? So this is how you should answer this question. And suppose if I ask, if TS is one standard deviation towards right, if TS is this, then what is this area? I know that this area is 34.1. So if I want to know this area, for example, right? So 50 plus 34.1, this is 84.1, right? And the remaining one is, so 50 plus 34.1, this is 84.1, 100 minus 84.1, you will get this area, right? So this is how you should be able to find out area under the curve, right? So let us move on to one more point. Now there is something called central limit theorem. In fact, this theorem will help us in knowing the characteristics of the project. I have already told you that the distribution of activities is like beta distribution, right? It's a right skewed curve, right? And I have also said that the project is a combination of hundreds of activities, and project has got a normal distribution, right? So every activity is like a beta distribution, but at the end of the day project is having normal distribution, right? So central limit theorem is actually a relationship between shape of population distribution and shape of sampling distribution, right? So if we take this activity as one sample out of all those activities, then the distribution of this sample would be like beta distribution, and all the activities will have normal distribution, right? Let us look at this question. Find critical path and variance along the critical path. What is the probability that the project will be completed in 28 days, right? We want to find out first critical path, then variance along critical path, and third, what is the probability that project will be completed in 28 days. Now, as I have told you that T at the last node is nothing but the project completion time, right? So as far as this particular project is concerned, T is 30.2. So the probability that project will be completed in 30.2 days is 50%, right? This is just one half of the bell shaped curve, right? Now let us find out what is the probability of completing this project in 28 days. So let me draw this network. So you have got 1, 2, 3, 4 and 5, right. These are 5 nodes. And you have also been given different time estimates. So, this is basically a PERT network, right. So, you have been given 3 time estimates for each of these activities, right. So, rather than writing all these 3 time estimates, let me write just the expected time which has been calculated using a formula, right. It is Tp plus 4 times Tm plus To divided by 6, right. So, T for 1 2 is 6, for this it is 10.7, for 2 to 4 it is 12.3, for 3 to 4 it is 8.5, and for this 5, right. Right. So, we have converted a PERT network into CPM network, right. So, let us start finding critical path. So, for that there are couple of methods. Either you just take T values at all these nodes and select the longest path, right, since this is a very simple network. So, you can do that. Otherwise, you need to calculate T and TLs at all the nodes and then find out where slack is 0, right. So, let us look at this. We'll follow the second approach, right. So, T is equal to 0, TE is equal to 6 here, PE is equal to 16.7, of course 16.7 plus 8, it is 24 plus 25.2. So, TE is equal to, TE at this is equal to 25.2. Just add these two once again. This is 1.2 plus 24, right, 25.2. But if you come from here, then it would be 18.3. So, we have to select the higher value, right. And then this is TE at this node is 30.2, right. So, the probability that the project would be completed in this much time is 50%, right. Let me draw distribution curve also, probability distribution curve. So, this is your TE which is 30.2, right. So, probability of completing this project is 50%, right, and this is the time for that particular probability, right. Now, let us find out critical path. In fact, you can easily identify it is from here to here to here to here, right. Okay. So, if you wish, you can calculate TL also. Let us calculate TL. In this question, we have been given what is the probability of completing this project in 28 days, right. So, this is scheduled completion time, and let us take this as 28, right. Now, 28 minus 5, TL is equal to 23, okay. Then TL at this point would be 23 minus 8.5. So, this would be 15.5, 23 minus let us say 9. So, it would be 14, 13.5. Yeah, it is 14.5. So, this is 15 plus 8, yeah, 23. So, TL at this node is 14.5. What would be the TL at this node? It's 14.5 minus 10.7, 3.8. Then the last TL would be what? It's 3.8 minus 6. So it would be TL is equal to minus 0.2, 2.2. So this TL is minus 2.2. TL at this point is minus 2.2, right? Okay. So what is the critical path? Where you got, you just calculate slack at all these nodes, right? So TL minus TE, a negative slack here, a negative slack here, a negative slack here, negative slack here, and negative slack here. So this would be your critical path. Right? Now the next question is variance along critical path. How to find out variance along critical path? So first of all, we have found out critical path is this, right? 1, 2, 3, 4, 5, right? How to calculate variance? We know that standard deviation is this, right? It's T P minus TO divided by 6, right? So for activity 1, 2, we have got all those 3 time estimates. So it's 369, right? So for activity 1, 2, it is 369. So 369, so 9 minus 3 divided by 6, and if you want variance, you will get 1. So variance is 1, right, for activity 1, 2. Similarly for activity 2, 3. For 2, 3, what are the different time estimates? It's 7, 11 and 13, right? So 13 minus 7, right, divided by 6. So 13 minus 7 is 6, 6 by 6, 1, this is also 1, right? And for activity 3, 4, you got 4, 8 and 15, right? So 15 minus 4, 15 minus 4 divided by 6 whole square. So this is 11 by 6. So whatever is that value, right? Take a square of that value. Then finally you got 4 to 5, right? 4 to 5 is, it's 3, 5, 7. So 7 minus 3 divided by 6. So this is 2 by 3 whole square, right? So you will get some value here. Just add all these values. You will get variance along critical path, right? Now after finding variance along critical path, what you want? You want to calculate what is the probability of completing this project in 28 days. Now this is something which you need to look at carefully. We found T is equal to 30.2. It means the project will be completed in 30.2 days and its probability is 50%. Probability of completing project in less than 30.2 is less than 50%. So if you want to calculate probability of the probability of completing this project is, let's say, 20 days. So that probability would always be less than 50%, because for 50% this is the value. Any TS, the scheduled completion time, less than this will have less than 50% probability. If I say what is the probability of completing this project in 40 days, and that would be more than 50%, right? Because if I say what is the probability of completing this project in 40 days, so TS becomes 40, right? And we need to calculate this probability, which would be more than 50%. In our question, we have been given this TS as 28, right? So TS is 28 here, right? So what is the probability of completing this project in 28 days? It would be less than 50%, right? But what is that value? So for that you need to calculate Z value, right? And Z is equal to x minus mu, right? Divided by standard deviation, right? Here mu is nothing but TE, right? And x is TS, or scheduled completion time, divided by sigma, right? So x minus mu, x is 28 minus 30.2 divided by whatever is sigma for this, right? So this you need to calculate, first of all calculate variance and then take under root of it, you will get sigma value, right? So let us take, let me exactly give you what this variance is. So variance along critical path is 5.8, right? So under root of 5.8 would be the standard deviation, which is 2.41. So this is 2.2 minus 2.2 divided by 2.41. Now look at what is this value. It would be, it is less than 0.1, right? So I think this minus 0.91, I think, right? Now this is your Z value. Now look at area under curve at this point, right, at 0.91. So we'll see the table, yeah. So this is Z value minus 0.91 and Z table is this, right? So 0.91, this one, it's 0.3186, 0.3186. So area under curve at 0.91 is what, 34 point, it is 0.91, right? So 0.3186, 0.3186, so 50, it is 50 minus 31.86, so this is, right? So this is the answer for this question, 18.4, right? Just see this, right? So this is how you should calculate answer to a question like this, right? Now if I ask you to calculate what is the probability that this project would be completed in 22 days, right? This is what we have just calculated. Just a minute, yeah. So this is the question we have solved. What is the probability that the project would be completed in 28 days? So this is 18.4, right? Now let us look at this network. Here T is 20. Now what is the probability that this project will be completed in 22 days? It's very simple, right? So what you need to do now, since this is more than TE value, Look at this. This is your T and T is 20, right? What is the probability that the project would be completed in 22 days, right? So it would be more than 50%, right? So calculate Z, which is 22 minus 20 divided by standard deviation. You need to calculate standard deviation for this. Standard deviation is 2. So standard deviation is 2. So this value is 1, right? So what is the area under curve when Z is 1? We will look at table, right? So area under curve when Z is 1 is 34.13, right? And it's 0.3413. You just add 50% in this area, you will get answer. It's 84.13, right? So in this way you can solve a question related to probability. Now you can also solve a question, what is the probability that this project will be completed within 22 to 18 days, right? So 18 to 22 days. In that case you need to calculate this area, right? So you would be calculating Z 2 times at Z is equal to 1 and 20 minus 18 divided by 2, right? So minus 1. So you just add those two areas now, right? So in this way you can solve a question given on probability. So let me summarize what we have done in today's session. We have taken a PERT network first, and then we converted into CPM network. After that we found critical path using T and TLs, and then after calculating the value of Z we found area under the curve from table, and we in the first question we subtracted area under the curve from 50%, and in second question we added area under the curve in 50%, right? So this is how you can solve questions related to probability. Thank you very much.